What specific problem does your proposed method address in the context of creative writing generation? And why is output diversity particularly important in this domain?
Our proposed method addresses the problem of low output diversity in large language models, LLMs, when generating creative writing, which can lead to homogeneous content and a limited range of responses despite the potential for varied and valid outputs. In the context of creative writing, output diversity is crucial because it allows users to explore multiple narrative paths and endings, enhancing the richness and creativity of the generated content. By incorporating deviation into the training objectives of post-training methods like diversified direct preference optimization, DDPO, and odds ratio preference optimization, DORPO, we facilitate both semantic and stylistic diversity while maintaining high writing quality. This approach ensures that the generated outputs are not only varied but also relevant and engaging, which is essential for creative tasks where unique perspectives and ideas are valued. Ultimately, our method promotes a balance between quality and diversity, addressing a significant limitation observed in existing instruction-tuned models.
How does the proposed method or algorithm work? Illustrate it step by step, particularly focusing on how deviation is incorporated into the training objectives of DPO and ORPO.
The proposed method incorporates deviation into the training objectives of direct preference optimization, DPO, and odds ratio preference optimization, ORPO, to enhance output diversity while maintaining quality. First, deviation is defined as the degree to which a training instance differs from other instances generated for the same prompt. In the case of DPO, the training objective is modified by weighting the loss of winning-losing response pairs with the deviation of the winning instance, emphasizing rare outputs over common ones. This is mathematically represented as L_DDPO equals E underscore X Y caret W Y caret L, text deviation Y caret W, CDOT frac P underscore theta Y caret L X, P underscore SFT Y caret L X, where the deviation term increases the likelihood of generating diverse outputs. Similarly, for ORPO, the loss is adjusted to include deviation in both the log likelihood and log odds ratio terms, ensuring that the model learns from both frequent and rare high-quality instances. This systematic incorporation of deviation allows the model to produce outputs that are not only high in quality, but also rich in diversity, as demonstrated by the results showing increased semantic and style diversity compared to traditional methods.
Can you come up with a simple yet illustrative example on the inner workings of your proposed diversified DPO and DORPO methods? Walk through the algorithm steps using a hypothetical prompt and the generated outputs.
To illustrate the inner workings of our proposed diversified DPO, DDPO, and DORPO methods, consider a hypothetical prompt. Describe a day in the life of a cat. Suppose the model generates three outputs. 1. The cat lounged in the sun, dreaming of chasing birds. 2. The cat knocked over a vase while playing with a ball of yarn. 3. The cat sat by the window, watching the world go by. In the DDPO method, we first calculate the deviation for each output based on their semantic and style differences. For instance, the deviation for the first output might be low compared to the second and third, as it shares a common theme of relaxation. The DDPO algorithm then weights the training objective for the winning response, e.g., the first output by its deviation, emphasizing its uniqueness over more common responses. This encourages the model to generate outputs that are not only high quality, but also diverse. Similarly, in the DORPO method, we apply a similar weighting approach, but also consider the odds ratio of the winning response against the losing ones. This means that if the first output is deemed the best, the training objective is adjusted to favor its unique characteristics while still considering the likelihood of the other outputs. By incorporating deviation into both methods, we ensure that the model learns to produce a wider variety of high-quality responses, ultimately leading to a richer set of outputs for the same prompt.
What are the practical advantages of the diversified DPO and DORPO methods compared to traditional DPO and ORPO, especially in terms of output diversity and overall writing quality?
The diversified DPO, DDPO, and DORPO methods offer significant practical advantages over traditional DPO and ORPO by incorporating deviation into their training objectives, which enhances output diversity while maintaining high writing quality. Specifically, DDPO and DORPO facilitate both semantic and style diversity, resulting in models that generate outputs with greater variation compared to existing instruction-tuned models like GPT-4o and CLAUDE-3. 5 Sonnet. The results indicate that these diversified approaches achieve diversity levels comparable to human-crafted datasets while keeping the quality of writing on par with state-of-the-art models. Additionally, human evaluations showed that DDPO both was frequently chosen for higher quality and diversity compared to both DPO and GPT-4o, highlighting its effectiveness in creative writing contexts. Overall, the incorporation of deviation allows for a more nuanced learning process that balances the influence of both common and rare high-quality training instances, leading to richer and more varied outputs.
How was the effectiveness of the proposed methods validated? Describe the experimental design, including the datasets used and the metrics for evaluating both quality and diversity of generated outputs.
The effectiveness of the proposed methods, specifically the diversified versions of Direct Preference Optimization, DDPO, and Odds Ratio Preference Optimization, DORPO, was validated through a combination of automated and human evaluations. The experimental design utilized the R Writing Prompts dataset, which contains prompts and corresponding creative writings, allowing for multiple responses per prompt. For evaluation, 1,000 prompts were sampled, resulting in 4,000 outputs, where quality was assessed using a trained reward model based on user upvote scores, and diversity was measured through mean pairwise cosine distances between outputs, focusing on both semantic and style diversity. Human evaluators compared sets of generated texts to determine which had higher quality and diversity, with significant findings indicating that DDPO both consistently outperformed both DPO and GPT-4o in terms of diversity and quality. Additionally, ablation studies were conducted to assess performance variations with different numbers of responses per prompt, further confirming the robustness of the proposed methods in promoting diversity while maintaining quality.
What limitations or potential drawbacks did you identify for your proposed methods, especially in relation to dataset size or quality of training instances?
One limitation identified for our proposed methods, particularly the diversified DPO, DDPO, and Odds Ratio Preference Optimization, DORPO, is their performance when the dataset size is small, specifically when there are too few responses per prompt. In such cases, the quality of the generated outputs tends to drop, as evidenced by our findings that indicated a decrease in Reddit reward scores when the maximum number of responses per prompt was limited to 4. This issue arises because a higher ratio of pairs may have zero deviation, which negatively impacts the model's ability to learn effectively. Additionally, while we found that tweaking the deviation term or using high-quality winning responses could mitigate quality issues, these adjustments often came at the cost of reduced diversity in the outputs. Thus, our approach highlights the importance of balancing the use of both frequent and rare high-quality training instances to maintain output quality and diversity.